Hello and welcome to NARC Live on Wednesday the 1st of December 2021. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7RP. Good to see you. On tonight's show, find out how to clean up your shack noise with Ian GM3SEK. We take a look at this brand new EMF calculator launched today. And it's all online, so you don't need to load spreadsheets or anything like that. And we find out what on earth is this. But first, no apologies really for talking about EMF again, because we've talked about it quite a lot as a club through this year. And of course, on the 18th of November, just a couple of weeks ago, it became mandatory for us all to make assessments on our stations if we transmitted on 110 megahertz or more. Well, the RSGB have been producing wonderfully more friendly calculators than the Ofcom one, specifically for amateurs, with things like antennas and things built in. But we know from some of the correspondence when we did a specific program on it a few weeks ago with our EMC advisors, that several people were struggling, particularly with running a spreadsheet and things which they may not have done before. Well, the RSGB have been working very hard to produce an online version, and today, the 1st of December, they've actually released it. So I wonder, Tammy, could we have a look at that quickly? Maybe there we are.
I can't get it any bigger than this, I'm afraid.
Okay, all right. But that's lovely. That's because we've all got a wide screen here. But there we are. Now that's actually a EMC calculator completely online. So you just need to go to a web address. I'll give it to you now. We will put it on again as well. But there is the general link from the RSGB to find that easily. But the link for this specifically is rsgb.org/EMC calculator, all one word. So EMC CALCULATOR. But you can find out and get links to this and lots of other information. Remember, it's not just about this, so the other information and all the support stuff and everything from the usual address, which is rsgb.org/EMF. We can't really demonstrate it here because I haven't even had enough time to play with it myself. It literally came live today, but it should help a lot of people.
Yeah, basically anything in yellow is sort of clickable, so you can change anything.
So you get the idea. The important thing, though, is you've nothing to set up on your computer, no free spreadsheets or anything like that. You can literally just go live onto this.
I'm not compliant,
okay.
I think.
You're not compliant, well, we're just putting those in at random. But there we are. You get the idea. So if it has puzzled you and you haven't quite yet done it yet, your assessment, if you transmit over 110 megs, remember it does apply to everybody, every amateur. If you transmit over that, regardless of your level, regardless of whether you use 10 watts or whatever, you need to assess your station, even though it may well come out clear that you are compliant. And this is the address at the bottom of the screen now to go to that specifically and directly. However, the one that we really recommend that you just remember is the usual one for the RSGB, which is this, rsgb.org/EMF. There's no signing in to do. The RSGB have made this available free for everybody, not just their members. But an awful lot of work has been done by John Rogers and his team, lots of colleagues as well, in producing this, and it really does look like an exciting addition. There's also, by the way, a new version of the spreadsheet. I think it's D today as well. So if you haven't already done it and you want to use the traditional way with your own spreadsheet, Excel or whatever, then you can also find a new version of it there. So it's continually improving. And I'll just say one more thing that we have when we've had John on the program before as well, is that he's always after help, particularly if you've assessed for unusual antennas which is not on theirs. Remember, they're just volunteers and they're trying to produce figures and everything for all sorts of antenna. So if you've done something like that, please drop him a line. If you want to, you can send it to me and I'll get it to John directly. That would really help them, because then you're helping lots of other people as well, because they'll share that information. Once again, then rsgb.org/EMF, and you can try out all these exciting new tools to make sure your station is compliant. Now we've heard from Nev, M0NFY, and he says, I wonder if you can help me with a small quest that's proving to be elusive. I enjoy reading the copies of Radcom Plus that come out from time to time. I download the PDF versions as I find the online animated offering difficult to cope with, often requiring paging back and forth to tie up images or schematics with the text. With the PDF, I can open multiple copies, and I can also zoom into the pages to assist with my failing eyesight. The interactive zoom functions are pretty much useless, in my honest opinion. Well, he says here, you'll remember that he spent most of the last quarter of last year in hospital, and as a result, he missed the issuing of Radcom Plus Volume 5, Issue 1, which is the one here. Remember, this is virtual. This is not a printed copy. This is something that's normally issued online. And so he's missing it from his collection of other issues in the PDF form because apparently it's only available for a short time. He says he's emailed the RSGB requesting that if they could help him get the missing issue, but his requests have so far fallen on deaf ears, not even an acknowledgement of his emails. So he's writing to us hoping that one of the viewers of NARC Live might have this missing issue on a PDF form that they would be willing to pass on to him. He is, of course, a member of the RSGB, so he doesn't believe this request is reaching any copyright. So if you're a member of the RSGB and you have PDF versions of Radcom Plus and you happen to have this one downloaded already, Volume 5, Number 1 that is, then please drop us an email. You can either send it to us directly or just ask us for Nev's email address and we'll be happy to put you directly in touch with him. Now, on last week's NARC Live, we showed you a digital microscope, rather an impressive microscope we felt, for a few £100. But Bob, G6PWS, has sent us details of his one and showed some incredible pictures of what he's able to do with it. More impressive than my penny, I think, that I put on last week, or a little one of our trained circuit boards. So this is some of Bob's pictures. He says, this is my digital microscope. It has an SD card for storage and a USB cable. It can all be recorded to a PC. He uses this for a lot of repair work, and it's good to show people what he's done. So if you have a look there on the left, you see that ring there that is showing there. Well, he says what you're looking at there is a ring antenna for an Apple Watch. Wow, because that's small, isn't it? It was a very erratic in connection to the Wi-Fi. Can we see the next picture, please?
We can.
So there we go. This is what it actually looks like. So on the left, you're seeing what it looks like to look at the microscope. And then on the right, he's showing the close-up of the screen and showing you what he's looking at. And that is pretty small stuff. He says it was very erratic in connection to Wi-Fi, but if you can see, as you can see, he's resoldered the joints at the top. And I used a pin solder nib. I bet you did, Bob. That is really very small. I guess for the scale, the bottom part of that microscope is probably centimetres, I'm guessing. So you can see the whole thing is only 8 centimetres across that sort of platen, which he's using on there. Anyway, he's reinstalled that antenna into the watch and it all works perfectly.
That's the actual little connector piece.
Oh yeah, look at that, it's for a connector. You should have put a penny next to that, and then we've got an idea of scale. That's pretty small. I have tried to replace a screen on an Apple phone once, and I could not believe the size of these incredible connectors. So I can imagine that's very small. Anyway, Bob, thanks for sharing that. That really does look good. And that isn't the only thing that Bob sent us this week. Let's go straight to this picture here. And he says, work out that one. Is it appropriate? Now, I didn't understand this, so maybe I'm thick.
Well, I just think that's a very large antenna, and to do the EMF calculations on it, that's what my take was.
What, the Eiffel Tower? Yeah. I wondered if it was some play on words like, that's an Eiffel.
No, I think it's a massive antenna.
I'm overthinking it. Okay. And there's, of course, the one of the Ofcom calculators at the top right as well. So, anyway, Bob, thanks for sharing that. He did those cartoons, himself. And that's clever. I wouldn't never do anything like that. Brilliant.
We've got just a couple of comments.
All right,
we should just go. Mike, G8EEY, says it's version 11D that they've just got on today.
Yes. I remember seeing D on there.
Yeah. And Neil, G4JUV, says, today I tried the new online EMF calculator. Guess what? My station is compliant and always has been.
Brilliant. Well, I'm glad it was useful. It is a lot easier to do from that. It looks anyway, and I haven't had a chance to try it myself, but it does look good. I did see also a comment that Bob also put a comment on BATC. He says, I've now got my call sign number plate.
Oh, yeah, we were talking about that last week, weren't we?
G6PWS. So
yeah.
We'll know when you come into Norfolk there, Bob.
Yep.
Thanks a lot. So, Tammy, Little people, what have you got to
Little
share
people,
this week?
yeah, here's the little people. This is actually the little people from yesterday. So I thought this was quite cool. It's the train barriers as plug sockets, or plugs, basically.
I see, yeah, so they're sort of, oh yeah, I get it. They're weird sort of plugs though, they sort of twist round, aren't they? They're like the barriers and, okay. Well,
this is Japanese, isn't it? So they must be Japanese plugs. So I just thought that looked quite funny though, because it's something so simple.
Yeah, no, it is really good how they innovate and just use some everyday object that wouldn't look quite like a UK mains plug, I guess, but
no.
more like a US one or something like that. But yeah, that's really good. Thank you very much, Tammy. Miniature-calendar.com. You can have a look at the pictures they do every day. Really inspirational, I think. Thank you. So, what have you been doing? We've had a few bits of news from you this week, but don't forget to keep in touch. You can always send us anything for the programme by 3 o'clock on a Wednesday, please, to this address, radio@dcpmicro.com. Right now, I wish you'd send a heater because it's very cold in here.
It's quite cold in here, yeah.
Yeah, we don't use this room much for during the week, and now the cold weather is here. It's sorry about that. I'm making an excuse in case I sneeze, which I've been doing all afternoon, or shiver or whatever. Just thought I'd let you know. Anyway, do let us know. radio@dcpmicro.com. Now, round to that competition. This is the one we showed last week. What do you think this is? What on earth is this? Now, we've had quite a few guesses. So, you start, Tammy.
Okay.
I've got a reason for that.
Have you? Okay. John G8VPE says, is it a bending jig for resistor leads?
Mike G8EY says, this week's What on Earth is this? Looks like a lead forming jig for bending the leads of components to standard PCB hole spacings.
Paul G3VPT, Elizabeth, which is his wife.
Yeah, she used to be called Linda, but she's changed it now to be, because Mannering and all that sort of thing.
She thinks it's, the Great Wall of China for the little people. Oh, it does look quite like that, doesn't it?
Yeah, I saved that from you when we rehearsed. I thought that it was good, though, because it does kind of look like that.
Yeah, it does, actually.
Doesn't it? For your little people.
Perhaps we'll have to get one and populate it.
No, you didn't want me to keep buying the things that
No,
we
I didn't actually want you to keep buying them.
I haven't bought anything for a couple of weeks. I bought a staplerless stapler and I bought wire strippers, but anyway. All right. Henry M0ZE says, this gizmo is for bending through-hole component wires neatly to 90 degrees.
Nev M0NFY, this week's bit of blue plastic, is it a device for storing sewing machine needles?
He's got a thing about this,
He's got a thing
he?
about sewing
I didn't make that up. You're looking at me as if, did you plant this? Well, we'll find out, Nev. You never know. Steve M0HET says it's a small component wire bending gauge for resistors and things like that.
Peter G0PEQ, it's a very handy... What?
You read it.
It's a very handy, as you can see, I have one.
Well, he sent a picture of one, but the trouble is, Peter, I can't give you any points because he didn't tell me what it was.
Oh, right.
So I don't know whether you're just being crafty and saying, I've got one of these and I don't know what it is either, or whether you really did know. Colin M0GMK says, this week's object is a jig for bending the leads of actual components to suit the whole pitch of a PCB. That's a really concise way of putting it.
Tom Miller G8XQD. Oh, he says again, is it the Great Wall of China for Tammy's little people?
I know, and that is unrelated. I don't know if Tom speaks to Paul or anything, but that is incredible to get two people say the same thing.
We're going to have to do. You're going to have to buy one of these this week.
What?
We're going to have.
Are you giving me authority to spend some money on something that we've used on? What on earth is this?
Yeah.
Great. I look forward to that. He actually also said something, a serious entry, didn't he? Which is an interesting one.
Oh, Tom, thinking it is it a BT Telephone's copper bundle spreader or the up-to-date equivalent broadband fibre spreader to separate out individual subscriber pairs? Ages ago, I had a 25mm thick by 45cm long cut-off with dozens of useful thin wires. Ideal for my electronic projects.
Because telephone wires, you have cables and they're all in pairs, aren't they? So you say they're 20 pair, 40 pair, that sort of thing. So it could be. I've seen them spread them out like that, actually, to put into a little crone box. Martin G3ZQU says, my guess is that it's a gauge for setting the correct spacing for actual leaded wire-ended components. Components laid at the appropriate point on the gauge, and then the leads of the component are bent down.
Paul G3VPT looks like a jig to enable the component wires to be bent at right angles for inserting into printed panels.
Yeah. Simon M0SIH says, this week's item shown on What on Earth is a jig for preforming through-hole component legs, such as resistors, capacitors, prior to soldering them into PCBs. Quite a range of things.
It was.
Little Great Wall of China got 2 guesses, but Tammy, reveal, what on earth is this?
Well, it was a component former.
Yes. I haven't seen one quite like this. I did guess that was what it was because Steve sent us the picture without telling us what it was. But it's not. It's a bit unusual because it does allow you to change the pitch as well as the depth and everything else. So it is quite good.
Yeah.
There. I can remember back a long time ago in the sort of 80s time when I used to have those electronic magazines that came out, and once on one of the fronts of the magazine they gave a free one. It didn't look quite like this, but anyway, those were the days. Anyway, thank you very much to Steve G3EVA for sending us that picture.
20TWQ's just said he thinks it might be a comb for different styles of hair.
I would never have guessed that, John. I can't think why. Anyway, all right. Well, thank you very much. That's a great one, Steve, for sending us that in, giving us a lot of fun as well. Okay, so let's now have a look at this next one. What on earth is this? I have a feeling this is going to be one of those things that you either know what it is instantly or you don't.
I knew what it was because I've got one.
Yeah.
Yeah.
Okay, so Tammy's got one. Have I got one? I think I might have one somewhere, yeah. It's not a torture tool, is it? Anyway, you have a look at that. And as always, we'll be putting this on the newsletter and on our website. And on Facebook, in fact, as well, just straight after the programme this evening. If you know what that is, let us know by Wednesday at 3 at the very latest to radio@dcpmicro.com. Good luck. Now, before we get on to tonight's main programme, main event, let's have a look at what's happening on the club this week. On Sunday at 7 o'clock, we've got the GB2 RS News on the repeat of GB3MB. On Monday, the 6th of December, we're into December. Can't believe it. Monday Night Net, this week hosted by Michael, 2E0SZP. At 8:30, we've got the 80-metre CW net on 3.543 megahertz. And next Wednesday, here on the 8th of December, we've got a talk by Tony G2NF on urban QRM. So that would nicely mesh with what we're going to be talking about tonight with Ian, actually. So that's about urban QRM, the sort of things we really struggle with. So that's next week on NARC Live at 7:30. And finally, every week, as you know, we offer to send a card to somebody celebrating a birthday or maybe not feeling well or something like that. Well, because it's now December, we thought we'd make it a bit more seasonal. And we've made this Christmas card with lots of Christmas images and other images of NARC Live throughout the year. And we'll be very happy to send this to anybody you wish. Now, that doesn't mean we're going to... Someone has said last year, I think they're going to send us the whole Christmas card list. It's not quite for that. But if you know someone, particularly if they're on their own, or maybe they're just feeling a bit down with this, or, not altogether happy out there, and you just think someone will be cheered by a Christmas card from your club, then drop us an email. The usual address is radio@dcpmicro.com. Send us their name and address, and we'll add your name to ours and sign it and send it and make sure they get it in time for Christmas. If they are abroad, that is fine, but please do that very quickly if so. So that's a NARC Christmas card to anybody that you would like us to send it to. Now on to tonight's main event. Now, our guest tonight is no stranger to us here at NARC and also to other programs that we do for the RSGB and things as well. It's let's welcome him and to find out what he's going to be talking about tonight. It's lovely to see again Ian GM3SEK. Hello, Ian.
Yeah, hello, David. Hello, Tammy. Hello, everybody. Thanks very much for inviting me, and well, especially for inviting me back.
Oh no, very much so. We're really looking forward to it. And I must say, if you don't mind, we'll share with everybody where you you live, because you live in Whithorn, I believe, Dumfries and It's between Dumfries and Stranraer, is that right?
That's right, yes.
So,
And
because
a long way south.
Yes, and because you've been up there and the weather is very much in the news with there, and we were a little bit worried this evening, and I think your 4G connection's not working, so let's hope we can make it through this. So we're really grateful. What is the weather like with you?
It's fine. We did very well in the west compared with the very unfortunate people in the east who caught the full strength of the storm. The only slight worry was you see that roof behind you. There were workmen on there still putting slates on Friday. So it just got done in time and immediately tested. But it's all good.
Good. Well, I'm very glad to hear it. It's really good to have you back with us, and you're going to help us now. When I first saw the title of this, Roger booked you to do this talk. It was how to clean up your shack. I don't think I was the first one to think, does he mean literally, tidying it up maybe, and even a vacuum cleaner or something like that? Because you're talking about the noise, the problem that we all suffer as radio amateurs, pretty much all of us anyway, particularly if we're in a sort of an urban environment with telephone cables and all sorts of things now. So you're going to give us lots of tips, I believe, to make the most from the conditions.
Yes, I hope so. This actually goes back to 2015. I've not given this talk since 2019. So, maybe better clean up your shack in front of folks again.
Yes, well, that would be really good. We'll leave it to you. Just a reminder to everybody at home, though, if you've got questions or comments for Ian throughout, just ask them immediately on BATC, or as soon as you can, rather, on BATC or Facebook, and we'll read them to Ian at the end. Over to you.
Okay, thank you. Thank you very much. And once again, good evening, everybody. This clean up your shack thing originated round about 2015, a little bit before. I had been doing some things about ferrite chokes and that kind of thing for interference suppression, but it was round about 2015 that I started to pull it all together into a plan to reduce people's noise, particularly on the lower bands. And we'll look in a moment where this noise came from. And then I did the talk again in 2019 and updated it. And essentially what you're getting are the slide pack from 2019, but updated, and I was still working on it about an hour ago. So yeah, it's as new as it gets. Yeah. So don't be too taken aback by the 2019 convention. Okay, away we go then. It's about reducing noise levels on receive, mostly for most people. And at the same time, the bonus, if you like, is it reduces the risk of causing interference on transmit, basically because you've got a grip on the situation. So what do we do? The 2015 talk was a full presentation, obviously, and I'm just going to gallop through that. That went on to YouTube later on at the end of 2015. The last time I updated this slide for 2019, it was 4.8 thousand views, and as of today, it's ballooned to 19,000. So either the word's getting round or things are getting worse. I very much hope it's the former. So for a lot of detail, I would ask you to go to the 2015 talk. But the other thing that's come online now is numbers of people have been putting up their own YouTubes. So if you just Google for the words YouTube and GM3SEK, then a lot of the there's a lot of good material there that other people have been putting up. So it's nice to think that this has been the start of something. And the thing that has been best of all for me is that there's been strong positive feedback. Yes, it works. We'll come back to that later. But what I want to show you is why we can expect these techniques to work, because if you want them to work for you, you need to understand a few things. So from the 2015 talk, that'll be the background. What we can do and how it works is very largely revised up to and including today. One thing that has been revised completely between 2015 and 2019 is the Mark II mains filter, which is this thing.
We'll just try and show that. Could you just hold that up there again? I'm sorry, Ian. It's just that we were mainly seeing the picture of the slide. So okay, that's really good. Yeah, that's lovely. Yeah.
Yeah. And I'm going to be talking about that quite a lot. That thing was built in 2019 at the end of the year. I took it, put it in the club room in Stranraer, and didn't see it again for 18 months because it was locked out. So, right. There'll be plenty of time at the end, of course, for a Q&A. So let's get on track with the background about RF noise and interference. I like to follow the American abbreviation RFI, RF interference. I find electromagnetic compatibility a little bit too academic, a little bit twee, and it doesn't tell you what it actually means. So RF interference, guys. And what we've had in the past 10 years in particular has been this perfect storm of RFI, of domestic RFI, the flood of consumer goods. There is so much electronics in our houses these days. And that has been coupled with the weak enforcement and failure to control the Chinese imports. And both of those, I think, have been fueled to a large extent by a poor understanding of what the technical problems actually are. So we end up with very little support from Ofcom. We have to do it ourselves, but hey, we're radio amateurs. We're supposed to be capable of learning about this stuff. But what we got is the world we live in is each of us individually. It's full of devices that can easily cause interference to amateur radio, otherwise known as spurious emissions of RF. And the flip side of that is a lot of it can very easily be upset by the RF fields from our transmissions. I'm not going to talk much about that, but about the immunity side, but we'll see how that fits into the story. So what can we do? Right. This to me has always been the most important thing. Don't give up. Don't slink off from amateur radio with your tail between your legs, because there is a heck of a lot you can do. And we've got to the stage now where there's a lot that people have done and have got positive results from it. So yeah, don't give up at the first hurdle. But learning what to do is, I think, to a very large extent, what self-training in radio communication is turning into for the century we're living in. So moving on, where does this interference come from? And I tried to list them in 2015, and it just scrolled all the way off the slide. But basically, most of it is due to devices chopping up the 50 hertz main supplies, switch mode power supplies of one kind or another, and producing large quantities of harmonics or digital data on mains and on phone lines. And if you pile this all together, even though it may be completely man-made, it just sounds like undifferentiated noise. So there is so much of it now of different kinds that it becomes rather difficult to unpick exactly how a lot of these noises are being generated. We just deal with it. Much more detail, as I say, in the 2015 talk, but the conclusion hasn't changed, which is that your main supply now is, for many people, especially in urban and suburban environments where you're sharing your main supply with lots of other neighbours, it's like a running sewer. There's no way I can put that to you any more gently. You can't trust the mains earth in particular to help you solve interference problems, and it may even make it worse. So a lot of what we're trying to do is to isolate the mains earth, the dirty mains earth, from the RF earth that we have in the shack, while actually preserving the safety green and yellow wire connection through all the metalwork. That has to be connected to the safety earth for the building that you're in, and there's no way around that. You can't just cut the earth wire. So that's where Clean Up Your Shack came from, and it increases your chances of hearing weak signals and decreases the risks of causing interference. And in both cases, the way it's done is by having RF currents flowing in the right places and having them not flow in the places where you don't want them. So the next question really is, well, two questions together. How does the interference get into our receivers, and how do our transmitted signals cause interference going out? They're obviously related, but it's easier to answer the second question first, because it's clearer what's happening when you think about the transmit case. So this is how it gets out. Welcome to a very basic stripped down amateur station. Transceiver, getting power from somewhere, power meter if you need one, ATU if you need one, and then a halfway dipole fed simply with coax up to the feed point there. So as we know, the inner conductor of the coax is connected to one side of the dipole, and the end of the coax shield is connected to the other side. Okay, that's fine. One more thing that you need to know about coax is, well, what happens when you transmit? And the answer is that the transmitted signal sets off up the inside of the coax, because what's happening inside coax cable is completely private from the outside world. And I can't emphasize that enough. It's something you can take to the bank. It's a piece of knowledge you can rely on at every level, from foundation up to, well, quite honestly, probably up to MSc level in electromagnetics. The inside of coax is private. It's as simple as that. So the coax just acts like a hose pipe, delivers the RF energy to the top on its two conductors. The center conductor, as was said, feeds one side of the dipole. The other side of the dipole is connected to the end of the shield. And at that point, what's come up the coax actually divides two ways. Some of the current goes onto the dipole. The rest flows down the outside of the coax, which acts as a completely separate conductor. And the fact that there's current flowing down the outside doesn't bother what's happening inside. So if you've got current spilling down here, it's usually known as common mode current, and it flows on the outside of the coax. The outside of the coax is acting like a single fat wire, and it's an antenna. Your feed line is radiating, as well as the current flowing down there. Now, the next thing is what happens to this current when it gets to the shack. One thing we know is it doesn't just dead end. The one thing we know about current is that it came from somewhere and it's going somewhere. It doesn't just dead end and stop. So where it's going actually is the bit of the drawing that we haven't included yet, that if you have safety earth continuity through all this metalwork, a lot of the current, often a lot, is flowing down the mains earth. And this is, it's nowhere near enough understood, but all I've been doing is using basic principles that we've all been taught and then probably forgotten about, like current doesn't just dead end. Right, so what's the effect of these RF currents, stray RF currents flowing through the shack? One is a collection of RF in the shack problems, including distortion on AM and SSB signals. In really severe cases, people who like to have a metal microphone and talk with it right up to their lips can get quite a severe RF bite. You know it, if you've got it, you know it's there. But there's more than that, unfortunately, which is you are actually pumping RF current into your own mains supply and making a free gift of that to the neighborhood. So what can we do about it? The first thing to do is, where was it getting out in the first place? And the answer to that is up there. So first thing we do is put a ferrite choke up there right by the feed point, which chokes off currents flowing on the outside of the coax. You can call it a balun if you like, because it tries to force the antenna to be more balanced. But for this evening's purposes, it's an RF choke, one of those things that stops RF from flowing along conductors where you don't want it. And if you do that, then the stray current is going to reduce. You may well need another one down at the bottom here, and in that case the current will probably reduce even further depending on the length of the feed line. And finally, you need something here to stop the RF getting out into the mains, which is the mains choke that I'm going to describe to you. And when you've done all that, you probably have cleaned up your shack from stray RF. You're not transmitting RF into the mains. You've reduced the feed line radiation, and everything is performing pretty much how it had been. Okay, I think that's clear enough. Every place that you stick an RF choke, it reduces the current passing through it. Right. Now, switch to receive. And how does this work? This time we got interference from the polluted mains supply. It's flowing through the shack. It's going up the outside of the coax. And it gets in at the antenna feed point, along with the signals that you're trying to receive. And at that point, you've mostly lost the game, because it's then up to you to sort out the signal from the interference that you've allowed to get in at the same time. The other aspect of this is that the coax shield is acting as an antenna that picks up noise locally and delivering that into the antenna feed point as well, unless you choke it off. So what you've got is the same solutions for both the transmit side and the receive side of the noise and interference problem. So blocking interference arriving, stopping any interference coming up the mains and interfering with anything else in the shack, and stopping or greatly reducing RF interference pickup by the feed line. So that's a win-win. How you do it with mostly Coax Chokes and with a choke-based mains filter as well. And I'll be describing these. So let's have a look at the Coax Chokes and balance first. As we've seen, these are the ones that are actually wound on your coax cable. Here's a little one.
So we're just going to come to you, Ian. If you can hold it fairly still for us, and we just have to do a little bit of jiggery pokey here. Thank you.
Okay, sorry.
That's it.
Okay, yeah. Here's a little one. You'll be seeing more of this, and that one is good for the higher HF bands. Here's one which G3TXQ had recommended, which is 3 stacked cores and is good across most bands as Steve had measured it. A lot of the Coax Chokes can be wound on a conventional toroid for lightweight. Just one little tip. It's very hard to distinguish between these toroids. So as soon as they arrive, get one of those sparkly pens and write down on the toroid what material it's made of. Trust me on this. You need it. Okay, moving on. There's been quite a lot of progress. I'll have to come back to the screen. Thank you. There's been a lot of work done by Steve G3TXQ, who sadly died almost 2 years ago now. More work in the States by Jim Brown, K9YC, who introduced a lot of these ideas to the world. And then there's this thing which I'll have to ask you to come back to the close-up, which is the large ferrite core by the Ferrite Corporation made out of their number 31 material. This has proved to be a game changer, and I'm going to have a lot more to say about this in due time. The other thing to be aware of coming back is that prices of ferrite cores are always changing, but every now and again you can come across a bargain, and there is one in particular that I'd like to mention later on. Coming back to Steve Hunt G3TXQ, who you may well recognize as the cobweb and hex beam inventor as well, or improver, should I say. Steve left quite a mark on amateur radio, I must say. One of the things he did in this area was to devise this sort of traffic light representation of how good ferrite chokes are, and basically what it is dark green gives you a very high choking impedance, light green not so much but often useful, yellow probably going to be okay for a number of problems that only need a lowish choking impedance, soft problems, if you like, rather than tough problems that need a high impedance. Orange, better than nothing, and red, avoid. Essentially, that's it. There's a lot more on Steve's website, and actually the first thing I did when I heard the sad news that Steve had left us was to archive his site. So I've put that on my blog at gm3SEK.com. As things have turned out, Steve's website is still up, but in the nature of things, we can't necessarily rely on that forever. So I've tried to archive it for a few years more at least. But I do recommend you go through it, and you'll quickly come to realize that you're dealing with a very bright guy. And he's, as I say, he's left quite a legacy. Next development, K9YC, Jim Brown in the States, and his choke cookbook, which is on the web. I'm going to leave you a reference at the end of all this. It was he who introduced the large snap-on ferrite bead from the Ferrite Corporation in the USA, and it's this thing. They are the only people who make this, what they call number 31 mix of materials for ferrite cores, and every mix has its own different properties. I think manufacturing ferrites is a little bit like the mineral version of being a baker. That you select your materials, you process them in a certain way, you cook them, you squash them, you heat them, and you come up with something that is completely unique to your way of baking. And that is definitely true of ferrite materials as well. So for 31 material is the best material for HF chokes. I should have written there. Transformers are a whole different game, but best material for HF chokes. Jim Brown was particularly into making very high performance chokes, which allowed him to do fairly daring things with 1500 watts of RF as well. Most of us don't need that level of performance. I think I finally kind of got that over to Jim. But this particular core is also, it's good for large cables. If we could come back to the general camera view, this is a mains lead, and I can just open up this bead and get 1, 2, 3, 4 passes through the center of the hole really quite easily. With a bit more effort, I could get 5 or even maybe 6. But you saw how little time it took to make that RF choke. So that means it makes a very good diagnostic tool. If you have a cable that you think there might be RF on, then you knock up a choke using this core, and you will know almost straight away. You can make more optimized chokes, certainly, but 4, 5, 6 turns through that is going to make a dent in most kinds of RFI and give you a very big clue to, okay, you need a properly designed choke here. So literally for special event stations, if we can even remember what those were, I would never leave home without a couple of these in the box, just in case, and it won't take long to make some improvement. So that core really has been a game changer. It's not cheap, but it's worth the money. Each core is going to be, well, it's going to be somewhere between 12 and 15 pounds, but it will do things for you. I mentioned bargain deals. Sometimes Farnell and RS have silly prices in both directions, so it's worth keeping an eye on them. But Mouser in the States have got this offer for free 3-day FedEx carriage on any order above, I think it might be $35. And because these chokes are not cheap, it doesn't take many before you qualify for this, and that really does work. They charge you in sterling, like a UK site, and they've got an arrangement with HMRC to collect VAT as well. So if you order something from Mouser on this deal, it's customs cleared while it's still in the air, and it comes straight off the plane onto a FedEx wagon. And even where I am, I can get things literally in 3 days. Just hand it to me on the doorstep. No more ransom demands like you get from other things like Parcel Force. So I do highly recommend that. They're usually, if they're not the very cheapest, they're still cheap.
Ian, I'm not trying to be smart, but I thought while you talked, I'd have a look and see how easy they are to get. As you said, Farnell and RS, they all have them in stock. And Mouser are the cheapest at the moment. Their price at the moment is £14.83 for one, but I think that's plus VAT, mind you. And then, yes. But it's amazing how price comes down. And although I'm sure one person wouldn't want 25, to give people an idea, if you bought 25 of them, which might be the sort of thing we could do as a club, that comes down to just over £10. So from nearly 15, it comes to £10 and 9p. So maybe if there's enough interest from people, we could get together a group sort of purchase.
Yeah, I think so. And yeah, as you say, you start to get the benefits fairly quickly. But the the free shipping is it is an absolute steal, because ferrites are horrible things, horrible materials to package and ship. They've got all the they're expensive and they're fragile like porcelain, but they're also heavy. And if you drop something with a large ferrite bead in it, it will have a mind of its own.
In fact, they have this down as a third of a kilogram for one. So they're quite heavy, aren't they? As you say, it's quite a good deal. So I don't want to interrupt the flow of your talk anymore, but just to ask, if you have a real interest in this and you'd like a few of them, if we can get enough interest, it needs to be serious interest, clearly, then I wouldn't mind, bulk purchasing on everybody's behalf. So
numbers of clubs have done that, and I had my heart in my mouth, quite honestly, when they told me they'd done it. But they said, "Yeah, you're right. They do. They are good, aren't they?" So
yeah.
All right. Okay.
Well, we'll take this away, and we've already had someone say they'd like to buy several. So again, if we do buy, if we can get together 25, which isn't much, if several of us bought 3, say, if that's the sort of number that you recommend in our spares box, then I'll put it on the newsletter. We'll get people's specific interest, and then we'll try and get a club purchase. But anyway, Ian, back to you.
Well, yes, thanks, David. Yeah, certainly have a look, and also bear in mind if you wanted to be making some more lightweight balance, then they also do the full range of toroids, and that kind of thing can be added into the order. Okay, right, and that actually brings us to the updated mains filter, which of course is this thing. That's where it fits in your station, and the idea is it filters the mains supplies to everything in your station, all the other little bits of stuff, those two. So I've waved it a couple of times. That's how it looked before it was mounted up on the board. And what we've got, okay, this is the plug, obviously, that goes into the dirty mains supply. The live and neutral go through a mains filter, a packaged mains filter. The incoming mains earth doesn't, and I'll show you why in a moment. But the basic principle is all the mains powered equipment in your shack goes through this filtered board. So that single socket strip may be part of something much bigger, subject to an overall limit of 13 amps. And I would encourage you to, if you build this thing, then follow what I've designed, and it will be good up to 13 amps. If you built things a bit lighter to make it cheaper, you will find that you run out of current handling. But okay, so first thing, it goes through a packaged mains filter. So live and neutral come in there, and they go through a balanced pi filter, pi section filter, and then there are also a couple of bypass capacitors to mains earth. But you'll notice live and neutral go through the filter, come out. Earth does not, because there's nothing to connect it to at this end. So what it does instead is the incoming mains wire goes all the way up to the other end of the filter, and you can see it going by there, and it connects onto the filter can right at the far end. Having done that, you've got 3 wires once again, which then go through a heavy-duty 2-stage RF choke. The first one, the core on which it's wound, is going to look awful familiar, and that is for the lower of the HF bands. It's good at 3.5 and 10. It's better at 7 megs. At 5 megs, it's spectacular, as it happens. But then the performance falls off. So we then have another smaller one covering 40 to 30 megs. The overall performance is measured in terms of impedance. How much impedance does it offer to block oncoming RF currents? And that's the big choke. That's the little choke. You can see that this is actually a resonant. It's a tuned circuit, actually. It's the inductance of the wire that you've wound onto the core, tuned by the self-capacitance between the turns. And as it happens, when you fill one of those up with 3 cores of big, thick wire, it resonates at 5 megs, and it's nicely balanced from 3.5 to 10. Below 10 megs, above 10 megs, its effectiveness wears off, which is what the second choke is for, and that takes us up to 30 megs. It's still there and doing something at 50 megs, but in terms of G3TXQ's traffic light presentation, it's good between 1.8 and 30 megs. Those were the design aims. I'm not claiming anything for 50 megs. So that's your RF choke. And then it comes out to the socket strip. The information about this is on my blog. If you just remember GM3SEK.com, it will very quickly take you to the page. You'll notice it's all in a plastic box because we've got we've stripped insulation off most of the cable, and we've got live terminals here. So yeah, put it in a plastic box, not a metal box, because that's just making extra problems for yourself. What are you going to connect it to? And the plastic box is cheaper. Oh, there's quite a lot more information in the slide pack that's accessible from my blog site. But the reason why we've got 7 turns here is that that's as many turns as I can actually stuff in there. The wire itself, the flex, is, I suppose you could call it heavy-duty kettle flex, or it's actually more like village hall urn flex, where it will continue boiling water all day.
So it's a good sort of 13, 16 amps, that sort of thing, minimum probably.
Well, yeah, it's actually one of the slides in a moment will give more details on that, but you can just get 7 turns through, and then that little fella is optimized for 14 to 30 megs on a different core, which if you were building these things, then I'm almost certain that the ones I got were from Mouser. Okay, the flex here, I bought it as it's 3 core, 2.5 square millimeter, and it's 90 degrees centigrade rated. That's a little bit important that the insulation is rated for high temperatures, because there's no air circulation or cooling inside that central hole. So the insulation on the flex itself has to do it all, and therefore get the stuff that's rated to be okay with getting a bit warm. Rest of the details are on things like how to twist that amount of cable with the cordless drill, and what happens when you release either end is it thrashes about and it's nowhere near as twisted as you thought it was. So you then learn to over twist it, and in the end it comes out right. Yeah. Okay. And from that slide pack, those are the instructions for how to make it. The small HF choke, yeah, there's a warning here. Those two cores are super glued together, and it sets instantly on contact. There's a bit of strange chemistry there. There's something about ferrite that catalyzes the reaction, but it sets instantly hard. So be very, very careful there. Right, back to how you use it. I do keep saying this: feed all the mains powered equipment in the shack through this filter and onto this socket board, and make sure there are no exceptions. For example, say you plug that into a double wall socket, which is your dirty mains, and you think, oh, I'm getting short of sockets here on the other side, but that's okay. My shack PC has got that's got a 3-wire cable, and it's got filtering inside. I'll plug it in next to the big filter board. No, do not do that, because what you do is you make an earth loop there that goes from the dirty side through your PC. It'll go straight through your PC like a dose of salts, because your PC doesn't have a filter in like this. And it then goes through the screened leads that connect your PC to the radio, and at that point you just basically short-circuited everything that you built here. So you make sure there are no sneak paths like that, which is not as easy as it sounds, but you've got to be absolutely sure that all means all.
Ian, may I ask a question at this point, which maybe other people thinking of? If you have more than, you're getting close to your 13 amps, maybe with your 6 sockets as you've got there, and so you need to filter others. Do you make another box and plug it into the other socket? You
do, because, well, unless you want to risk too much current going through there, then you do have to do that. But as people have found out, something that's rated for 13 amps will actually power. It'll certainly power an HF station with a small linear. For various historical reasons, I've got a separate choke on my linear amplifier, because literally, and I mean this, I have very, very long feeders. It's not an excuse, but yeah, you would have to make another. There is a slight problem with that, because when everything is bonded together at both ends of both boards, you only get half the impedance from the pair of chokes that are effectively in parallel. So you should be okay. Let's put it that way. With 13 amps, provided you go for that from the beginning, you're gonna be running quite a lot of power before you before you run into any difficulties there with that 13 amp rating. So having said that, I think it's probably time to move on to the feedback part. When I first did this in 2015, again, my heart was in my mouth, because I know this is good engineering. I know it's built on good basic principles, but if what I think is a problem had turned out not to be a problem for a lot of people, then they might be coming after me wanting some money back for what they spent on ferrite. However, that turned out not to be the case. Okay, just recapping, that was the problem. The solution works. There's an improvement on both transmit and receive. And, sorry, I went a little bit too fast. There's an improvement for both transmit and receive, and this was what people had been reporting. Originally, I'd underestimated how much people valued it for receive, as well as for curing any RFI complaints that they had. But yeah, the word comes back. It worked for me, and that's very satisfying, actually, as well as being a considerable relief. So also, things have started to come back, as I said, on YouTube. People putting their own conclusions up there. If you go onto YouTube and then search for GM3SEK mains filter, you'll start to see things that people have put up themselves. So I'll just put three up. One is Ian G0CNN, who was also the guy you saw in Radcom a couple of months ago on the front cover with his receiver and his little loop, chasing down interference around the housing where he lived. He built this mains filter. He doesn't actually have mains-borne problems at home, but he does with his inverter generator. And he showed a lot of before and after pictures of the waterfall on the radio with and without the mains filter. He also found that sometimes it helps to turn it around the opposite way, which is, again, something to try to improve if you can. EI2IP, I like this. I built two straight away. They work, no brainer. Well, yeah, okay, thanks. Thanks for that. Again, a relief that I can feel more confident now. G0MGX, I'm not going to tell you the whole quote, but it's embarrassing, but he is a fan. So, yep. But what he said was, yeah, just do it. But of course, it works, comes with a few terms and conditions. One is that it will only work if you have the specific kinds of RFI problems that we've been talking about. If you don't have them, then you'll put this filter in and it won't make any difference. Okay. Somebody did pop up a YouTube about that. He was saying that his club members had asked him to do a YouTube, and because he built one, and he said he'd been a bit reluctant because he didn't have any particular problems. It didn't make a difference for him, but he did put one up in the end, and he was quite understanding about what the situation was that he was dealing with. But that said, that kind of problem is very common. So it's well worth a try. But also, it's very easy to find out if you've got a problem. Once you've got a few of these handy little things, it's very easy to wind a quick choke or two. All you need is some slack in the cable, and see whether that makes any difference. If it does, even a sort of random 4, 5, 6 turns through here it'll put a hole in most kinds of main spawn RF interference, and that will give you a good clue to say, okay, I do have a problem. I'll go on and build the whole filter. So yeah, please never underestimate the value of these things as just as diagnostic tools. That's another reason why I never run out. I've always got at least one in the shack. All I have to do is remember where I put it. But okay, well, thanks very much. This is the end of the planned bit. So yeah, thanks for watching. I hope you found it useful. And okay, I'm here all night.
Well, okay. I don't think we'll need you to be quiet all night, but we have certainly got several comments and questions as well for you. So thanks for those. But if you have got a question for Ian or a comment or anything, you've tried something like this, then this is the time to put them either on BATC or on Facebook. So I'll start, if you're all right, with this. And one comment I saw earlier on from Steve Webb, who just says, need to be very careful with adding turns, because the more turns, the lower in frequency the impedance peak becomes.
Yeah, that's right. That more turns is not always better, because, as I said, it is a resonant device. It is a broadband tuned circuit. So don't be like the guy who decided he needed a big RF choke for at the base of his top band vertical. So he put in a 100-meter drum of RG213. More is not better. The right number of turns is
the right thing. Right. Okay. Thank you. Several people, actually quite a lot of people, saying they like several. I mean, 3, and someone else wanting 4, and someone else wanting 5. So it does look like I've volunteered myself to try and do a bulk purchase. But I appreciate. Yeah, and I appreciate you guys putting this on Facebook and BATC, because it gives us an idea, expression of interest. But I think you'll appreciate, because we're talking about quite a few £100s, what I'll have to do is make it a little bit more formal. We'll put it on the club newsletter, which will also be on the website, of course, and we'll ask you probably to commit to them on an email. And of course, needless to say, and looking at the prices earlier on, the more we buy, the cheaper it will be for everybody. But if we can get to I think the magic number would seem to be 36. They seem to be in trays of 36. So if we can get to at least that, which, looking at the number of people who had said they'd want 3 or 4, may not be so difficult. So that will reduce the price significantly, probably by about 40%, I think.
Yeah.
Anyway, so some other questions coming up on BATC. Tom G0JSV says, I've a question for Ian GM3SEK after the presentation. I've been plagued for many years from an extractor fan in the local pub. Most of the HF bands are wiped out, interference spaced at 8K intervals 150 metres away. Worst on 160 and 80, but goes up all the way to 15 metres. What should I do, he says.
Yeah, I don't think that's going to be the kind of problem that that this will help with. Certainly, it's worth trying chokes on your coax, or depending what type of antenna it is. It might be worth trying chokes on the coax. It seems less likely that it's coming up the mains. Depends which phase you're on as well, but otherwise there's not an awful lot you can do pub landlords.
He does. Well, he does add a PS that I ought to read you, Ian. Sorry to interrupt, but he does say, as a PS, on friendly terms with the landlord, he does accept that the interference is caused by the fan. So maybe, I guess what you're suggesting is you might be able to persuade them to try a couple of these ferrites on the fan wires, maybe.
Possibly, although it may be just due to the design of the motor itself. And yeah, I hate to say it, but it might work out best to buy him a new fan if it's not a big one.
Well, yeah, that could be. I guess, yeah, that would be maybe a certain, especially if it could be. I'm trying to think what they are called without a brushless motor or something. That would be ideal, wouldn't it? If it's the right kind of brushless motor, I'm not totally familiar, but as long as there isn't anything in there that's going chopping up the mains, which I think is the fairly obvious source of this interference. Yeah, it's quite difficult, even if you wanted to buy another fan or a fan for your own bathroom, for heaven's sake. It's very difficult to know what kind of electronics there is in something as innocent as that today. Yeah, absolutely. Now, as you say, cheap electronics, often involving switch mode power supplies to reduce voltages, they can be some of the worst, can't they?
Yeah, and you don't always get what you pay for in this particular regard.
Neil, a useful tip from Bob Fuller, G6PWS, I think. He says, I use a heat gun to heat the twisted cable gradually to help them set better, which I think sounds a wonderful idea, as long as you don't overcook it.
Yeah, that's a good one.
So it's just, I guess, the plastic wants to go straight, the insulation, and I guess if you warm it up gradually as you're twisting it round, it's more likely to slightly form better, is what he's saying. That's a really good tip, Bob. Thank you for that.
Yeah.
Neil Bauer says, how about a club kit for that mains filter? Well, we'll see what we can do. I'm not sure we're into providing every single little bit that you'd need, but we'll maybe look at the case and other things if there's enough interest in this, and I'll certainly sort of have a look at some costs and things like that very soon. Several people.
The one other major item I think is the mains filter. So you might be able to get some price breaks there. In other ones, there's all the rest of the stuff, the plastic box and so on. And I got the cable off eBay. I can't remember where I got the box from, but those are less
difficult sort of thing.
You're spending your time on, I think.
Yeah, I think the important thing is to try and bulk buy for the club, isn't it, for the bits that we need to. Christy0DWV says, I have a separate main circuit on its own breaker to the shack. Can I build one specifically to support the shack circuit, circa 32 amps, and install it at the consumer unit, he asks?
You probably couldn't because of the problem of getting enough wires through the center of that core, and unless you wanted to do something sort of fairly elaborate with large cores stacked up, I don't know, Chris. I mean, it's doable, obviously, but you'd be starting from scratch with the design of the chokes. That's the main difficulty. A mains filter, no problem. They're available, obviously, at higher current ratings. It's not something I'd looked at, but I can see the attraction of that, certainly.
Okay, thanks. Is there anything specific to watch out for with the filter then? Are there any, you mentioned about the configuration, the pi configuration, I think it was, of the capacitors and things on there. They're not critical?
They're not especially, no. The only problem I've had was to do with Oh, most of you probably know the lady. It was that Delia Smith. I don't know whether you've heard of the Delia effect.
I think that us being from Norwich, I think, or very near Norwich, I think we might have heard of her, yes.
Yes. Yeah. Have you heard of the Delia effect?
When she said something, didn't she use something in a recipe and then everybody sold out quickly?
It just disappeared.
Right. Okay.
That's exactly, that's happened to me twice with mains filters, actually, that it just cleaned Farnell out. So on the first occasion, we had to wait. But since this is a fairly bog standard mains filter, I just switched to another, and it's not going to make an awful lot of difference.
Okay, thanks. Well, I've got through my work.
Yeah, just watch that Delia.
I will do. Let's not mention it. I will watch that. I've got access because of my work to sort of a lot of the big trade suppliers. I've got accounts with most of them, and including Mauser and Farnell and RS and things. So I'll have a sort of good look at that and maybe even run it past you before we do commit to any large quantities. But thanks for the tips. Better get back to some of the questions now. Roger G3LDI says, I've made several of the 3 oval toroid chokes, but they are heavy. Do you have any extra support in the centre, and is there much sag?
Yeah, I know the ones Roger is referring to. Those are from a much earlier article when ferrite was very expensive. I devised a series of chokes based again on work by somebody who'd gone before me, which were optimized, making optimum use of these little oval cores. And yes, they are well, whatever you do with ferrite is going to be heavy, but if you're thinking about suspended weight, then I think probably the best kind of impedance to weight ratio is going to be a 2.4 inch toroid using one of the recipes from either G3TXQ or from K9YC. I obviously wouldn't try to suspend one of those from the middle of a dipole unless I really, really had to.
No, but it's very, very useful. In fact, they clip on, isn't it? That's
yeah.
Really. Colin now, G0ODR, says, do we not have to worry about RFI from 30 megs and up?
Less so. It's still there, but it's not quite as serious for most of the people most of the time. It is for me because I'm a VHF DXer, but for the higher frequencies, then things like toroids and large cores like this are no use to you on higher frequencies, because even a single turn, a single pass through would be too low, would have too low a resonant frequency. So at higher frequencies, you end up being driven back towards selecting small ferrite beads, strings of ferrite beads. I've talked about that in a separate presentation on VHF balance, where there are numbers of people now going towards using smallish ferrite cores for those frequencies. It doesn't work as well as a toroid with a lot of turns. It means you need to use more beads, a lot more beads, but it's what we've got. That's just physics.
Sure. Okay. I think we're all interested in the pub fan problem. We've had a few bits of feedback and things from that. Tom has come back and said that it is a big fan and it calls the pub kitchen. And he says, and Wolfgang, by the way, Wolfgang DL1BJV, one of our regular viewers here, says that thank you very much, Ian, for the excellent and comprehensive presentation. And he goes on to say, if the fan has a speed control, that could be the cause. And Tom has come back and said, yes, it actually does have a speed control, and I'm pretty sure that that is the main cause. I can see variations in the signal strength from time to time during the day, but the spacing remains at 8K, he says. So, well, hopefully these things have helped Tom and his friendly pub landlord, and let's hope that helps solve that. Got some more comments here. Stuart Brooks says, I've got a constant bus, then it goes off the buck on S7 signal. Does that? I'm not sure I understand that, but so I've got a constant bus, then it goes off the buck on S7 signal. So I might be one of those autocorrect things, maybe, Stuart. So if you'd like to come back to us with exactly what that means, I'm not sure myself. All right, Stuart. Well, we'll do come back, Stuart, with that, and again with it slightly reworded maybe, and we'll read that to Ian. Paul G3VPT says, a most interesting talk. When we operate a special event with the Scouts, all our radios are fed with 500 watts, so we can use an RF earth. We also have 1,000 watts. I guess he's talking about the power now, the mains power. When the computer is also linked to the radio, would the large iron core reduce the QRM there?
It depends. I think you're talking about generators there, aren't you?
I'm guessing it might well be, because
Yeah.
let me just have a look again. I'm knowing him. They do work from a sort of scout hut, which is a permanent place, but maybe yes, maybe it is generators.
Yeah. If it is, then I'd very much recommend having a look at the YouTubes by Ian GM3SEK. Because he seems to be the one who's done most of the work. It depends what frequency you're on as well. I mean, sometimes an earth stake will help with generator noise, and sometimes it won't. And oftentimes you don't know whether the earth that you tried to put in there was actually any good. It needs the only thing to do, quite honestly, is to experiment.
Yeah.
Try and see.
Okay, I think we've got that. Tom comes back and says, how come Ian has got a steady, constant connection all the way from Scotland, yet when I listen to Radio 4 in the morning, every second caller is cut off? Because, I mean, you and I were worried. I think it's fair to say, tell everybody that it was only at 7:28 that we made the connection with you, and you were worried that your 3G would work. I have to tell you, it's been really good, actually. Very good.
Yeah, it's 4G, but there have been some problems since the storm weekend before last. That there have been some difficulties with the signal had just gone off, and usually I try, if it's something like this, I try to reboot the router so that it starts off with clean buffers, and I tried to do that after we had spoken to one another, rebooted it, and oops, didn't come, no signal. I think it was a coincidence that the signal had gone off, and it was right at the last moment that, just for no reason, it came back on. But the alternative, I'm afraid, is currently running at about 1 meg download and about half a meg or less upload. So not suitable for this kind of two-way video.
No, well, it's worked really well anyway.
It has, yes.
Very well. Wolfgang DL1BJV comes back and says, if it's a phase control, it could be a capacitor filter problem. Another question is it interfering via mains, RF, or both? And I guess he's talking to Tom there with a problem with that fan in the pub. So I'll let Tom answer that, because I don't think you probably can, because Tom will have done some research. So we'll let you know how he's coming. I've got Stuart Brooks has come back and said, buzz on and off right through the bands with an S7 signal. So maybe he's getting a buzz on and off continuously, I guess, all the way through the bands. So maybe he's asking, do you think this is going to help? I guess you've got to decide whether it's mains-borne interference, isn't it, from the first things?
Yeah, that's the first thing. But if it is something fairly local but not mains borne, then by all means, put choke balance on the coax and see if that will help.
I guess, Ian, let me ask you the question, you know, with that, especially with that clip-on clamp that I know is fairly expensive, but, you know, if a lot of us do rush out and buy 2 or 3 of those to have, it is a sort of thing from what you were saying earlier that you could just wrap your mains cables and other things around and just see, does that have a difference make the difference to the noise floor?
Yeah, many a time we've done that. The local Wigtownshire club, we've got lots of lighthouses to choose from, so we do lighthouse weekend every year, and no matter how much we try to test the stations, they end up with other people's gear plugged in as well, so that you get somebody wants to bring their own laptop, for example, and next thing you know, you have interference from that, and in that case, we just sort of run along with the large ferrite bead and try it at both ends of the or each end individually of the power supply lead and see what works. That's how it works out in the end, but you can't do that if you don't have them with you.
No, sure. Well, I think you really have made an excellent impression on people, because as I say, lots of people have committed and said, I'd like some of those. So I'm sure that we'll be getting a club, something club together. Oh, just got another message now from, I think, John Goldsmith, I think that is. Reference unreliable connections. Radio 4 just had to omit a whole programme as several of the participants in the discussion sounded like they were 100 yards away, and it took the engineers ages to notice. Oh dear. Oh well. Well, we're not Radio 4, we're watching Norfolk Amateur Radio Club here on NARC Live.
Yeah, who are very, very good at these things.
Well, we try.
I'm perpetually grateful every time, and I know I'm in good hands. Thank you very much.
Thank you. Well, that's very kind of you. Thank you. I mean, the last time we met actually was a few weeks ago when we were hosting the BATC convention. And you,
Yep.
I was going to mention this if we had a moment. I mean, you must be pleased to see that online calculator that John and his team have put up. I know you do work with that team, don't you?
Yeah, I do. And well, it was a coincidence actually that our club president, Ollie MM0YOS, is a computer consultant, and he looked at. I'd done presentations for the club. He looked at this at the Excel version and listened to the complaints of the hardened Linux users and so on, and said, "I know another way to do this," and that's what we've got. So it was just an absolute stroke of luck that he got it into his head to try and do it. And I said, "There's a guy called John Rogers you ought to meet."
Yeah, it's excellent. I mean, John and his team, they do a fantastic job. And every talk, I think, and we must have hosted 4 or 5 things this year with various RSGB things. And I know each time he says that his call sign M0JAV stands for just another volunteer. So, and it's true. But anyway, Ian, once again, thank you ever so much for tonight. It's been enlightening, and what you can do with relatively, 30, 40 quid, it could change your hobby even for you. So I think you've been inspirational in telling us how to do that. I promise to sort of get some prices and things together of the main bits that people need, and then publicise them to the club. And maybe I just say I might run it past you first, especially with that mains filter, just make sure it's going to be suitable. But once again, Ian, thank you very much indeed for joining us again. GM3SEK, coming up all the way from Scotland. Take care.
Thank you. It's been a pleasure.
Best wishes. Thank you very much to Ian. There we are. Just another rundown of what's happening at the club this week. On Sunday, we've got the GB2RS news on GB3MB repeater. Monday, the 6th of December, sees the Monday Night Net with Michael 2E0SZP at 7:30, 8:30 on 80 metres, 3.543 megahertz as a CW net. And next Wednesday here on NARC Live, the 8th of December, we've got a very complementary talk to this, really, all about urban QRM. So specifically looking at the QRM sort of sources and problems and things like that. And that's a live talk by Tony G2NF. We look forward to that as well. So keep in touch with us. Don't forget, we've got this Christmas card that we're going to offer. You know, we're asking you to let us have names and addresses, not your complete Christmas card list, but someone who might really appreciate it, especially this, you know, as we enter into slightly more difficult times, maybe this Christmas. We'll be very happy to send that from you and from Tammy and me as well. But that's it for now. We'll look forward to seeing you again next week on NARC Live at 7:30. But for now, from Tammy M0TC.
Goodbye.
And from me, David G7URP. Take care. Bye-bye.